Hi there. Now that we know what is Hive, what was the motivation for Hive, and what are the used cases for Hive, let us try to understand what Hive is not. Hive is not a database. To understand further, let us see the difference between RDBMS and Hive. RDBMS stores data, whereas Hive uses data which is already stored on Hadoop and does not store actual data. RDBMS support for both OLTP and OLAP transactions, whereas Hive is for online analytical programming. Hive is traditionally used for large-scale volumes. Hive is best suited for data warehouse applications where there is no need for real-time responses to the queries. Hive looks very much like a traditional database code with SQL access. However, because Hive is based on Hadoop and MapReduce operations, Hive is more used for batch processing. Hadoop is intended for long sequential scans, and because Hive is based on Hadoop, we can expect queries to have very high latency. Latency for Hive queries is high even for a small job, which means Hive would not be appropriate for applications that need very fast response times. Hive is not 100% SQL, that is, HQL is limited in the commands it understands. Not all SQL commands work on Hive. For example, updates and deletes are not supported. Let us try to understand what it means on a sample table. In this sample table, we have 4 users who have given ratings for 4 different kinds of movies. If we want to delete Sam rating on documentary, in an RDBMS table, we can run an update query to update this particular value to a different value. Whereas in Hive, we cannot update or delete a particular record or a row level transaction. But Hive supports overwrite of this entire table or appending a 5th user to this table. Now let us proceed to discuss Hive architecture. Hi everyone. In this video tutorial, let us do a quick recap of Hadoop architecture. Hadoop comprises of HDFS and MapReduce. HDFS has 3 components: name node, standby name node, and data node. Data is stored in data nodes and name node manages metadata. Metadata is data about data. Let us say, if we have a file in HDFS, the file will contain the data, the name of the file and permissions on the file are considered to be metadata. Whenever a file is moved into HDFS, file is divided into blocks and the blocks are replicated across data nodes based on a replication factor. Default replication factor is 3. Whenever a client tries to read the data, name node provides information of the blocks related to the data and client will read the data from data nodes. MapReduce 1 has 2 components: job tracker and task tracker. Jobs are submitted to job tracker and tasks are forwarded to task trackers. A task can be either a map task or reduced task. Once map tasks complete their work, or at least major portion of map tasks complete their work, reducers work on the output generated by the map tasks. After reducers complete their work, output can be either returned to HDFS or normal file system. This completes a recap on HDFS and Hadoop. This completes a quick recap on Hadoop. Let us try to understand Hive architecture. In this video tutorial, let us understand different modes of running Hive. The three main modes that we are going to discuss are embedded, local mode, and remote mode. Let us proceed to discuss on embedded mode. In the embedded mode, the metastore is divided into two main pieces, a service and a backing store for the database. By default, the metastore service runs in the same JVM as Hive service and contains an embedded Derby database instance. In this mode, both database and metastore service run embedded in the main Hive service JVM. Whenever we start a Hive server process, both the processes get started. This is the default metastore deployment mode in Cloudera distribution of Hadoop. Even though configuring this mode is quite easy, this is not recommended for production. Drawback in this mode is it can provide support only to one active user. In this embedded metastore service communicates with metastore database over JDBC. Let us proceed to discuss on local mode. In the local mode, the Hive server process and metastore process runs in same JVM. But the metastore database, in this example MySQL, it runs in a separate process. Here, Hive service refers to either a Hive server 1 or Hive server 2. Finally, let us discuss on remote mode. In this mode, Hive metastore service runs in its own JVM process. Hive server, metastore, and the database are all separate processes. When Hive is implemented as a remote mode setup, analytical tools such as Datamir, Platfora, or Cloudera Impala communicate with the metastore via a Thrift Network API. This is configured by a property hive.metastore.uris. We will exchange the metastore host as well as the port where metastore is listening with other analytical tools like Datamir and Platfora so that they would be able to communicate to the metastore. The Hive server process, metastore process, and the database service can all be on a same host, but running the Hive server process on a separate host provides better availability and scalability. The main advantage of this mode over local mode is that remote mode does not require the administrator to share JDBC login information for the metastore database with each Hive user. Command line interface. Whenever we log into a shell, when we type the word Hive, it takes us to the Hive command prompt. As we know, Hive is installed on the proxies. When we log into a proxy and run the command Hive, it communicates with metastore. In this case, if metastore is down at any point of time, Hive commands cannot be run. We will see a demonstration once we have a VM setup. Hive can also be accessed through a bspecs application which runs on Hive. Hive has a Beeswax application. This Beeswax application feature includes running the queries, creating the tables, browsing the tables, and saving the queries for later executing. We will take a deep dive into this during our demo tutorials. User logs into the Hive, then he would navigate to Beeswax process. The Beeswax application would connect to Metastore either through a Beeswax process or through Hive server 2. In recent times, Beeswax process is deprecated, so Beeswax application always connects to Metastore through Hive server 2. Once it establishes the connection to the Metastore, Metastore would connect to the backed up database. To summarize, user logs into Hive, navigates to Beeswax application, runs a query, the query connects to Hive server 2, Hive server 2 in turn connects to Metastore, which would connect to the database. I thank you for watching this tutorial. First, let us go to a browser and go to cloudera.com. Click on the Downloads tab. Here, choose Quick Start VMs. At the versioning, choose CDH 4.6 for our testing purpose. Then, based on your available platform, download the VM image. For our lab purpose, let us download VMware. We can observe that Cloudera Quick Start VM is downloading onto local machine. Once the download is successful, we will bring up the VM through our VMware player. I will be providing all the links in the exercise section to download the VM as well as VMware player. Let me pause this video for a moment until the download completes. Now that download is complete, let us unzip this folder. Alright, now that the unzipping of the file is completed, let us go to the folder where VM is downloaded and double click on the VM machine configuration. This will fire up the VM. Once we get the booting screen, we can consider that VM would come up without any issues. Okay, once the VM is up, it will open up a browser with all the favorite links to everything we need here. The first link that we can consider here is Cloudera. The second one is Cloudera Manager, which helps us to manage the Cloudera Hadoop on the VM. We have third link as Hive. Then we have HDFS name node, which will provide the details of HDFS. Then we have job tracker link. Let us go ahead and log in into the Cloudera Manager. Okay, now that Cloudera Manager has provided the login screen. Login with credentials Cloudera and Cloudera. As we discussed earlier, Cloudera Manager is an application to manage Hadoop. Cloudera Manager will make it extremely easy to interact with Hadoop cluster. With the help of Cloudera Manager, we can configure, monitor, and also report on the usage of the cluster. Here we need to remember an important point, that is, if Cloudera Manager goes down, it does not impact the Cloudera Hadoop availability. The only drawback is if Cloudera Manager goes down, it becomes extremely difficult to manage the cluster. Cloudera Manager has two main parts. One is Cloudera Manager Server and another one is Cloudera Manager Agent. Agents run on across multiple servers in the cluster and they keep sending the information about the respective components which are running on the servers to the main Cloudera Manager server. Let us proceed to understand more about Hive service by understanding the configurations and other properties inside Hive. Click on the Hive. As we can see, there are different status options available here. First, we have a status summary where Hive will provide whether all the services related to the Hive are running successfully or not. The green mark here indicates that the services like Hive Metastore server, or if we install any other service, Cloudera Manager will mark the service either red or green based on how the service is running. If there are issues in finding out whether the service is running with good health or with bad health, then Hive will display that the status is unavailable. If the status is showing as green, that means Cloudera Manager is getting the status from the Cloudera agent which is running on the host where Hive Metastore server is running. Let us say if we have Cloudera Manager server running on the server 1 and we have Hive Metastore server running on a master server 1, then Cloudera Manager server will communicate with the agent which is running on the master service. The agent will grep whether the Hive Metastore server process is up and running. Then agent will communicate to Cloudera Manager server that HMS process is running without any issues. Once Cloudera Manager server receives this signal from the agent, then it would be marked as green, stating that Hive Metastore server is running without any issues. Let us say if the Hive Metastore server is down for some reason, then the agent will update accordingly. Then Cloudera Manager will mark this service as red. Please note that if there is no connection between Cloudera Manager server and Hive Metastore server because of some network issues or because of agent is down at master server level, then the status here will be displayed as unavailable because server is not able to communicate with the agent. More details about how Cloudera Manager and how to administer using Cloudera Manager, I will try to put up a separate video tutorial for a better understanding. For now, let us try to understand different options available here. Let us click on the instances. The instances page will provide details about where and on which server all the processes related to the Hive are running. Click on the instances. As we can see, we can find out that Hive Metastore is running on our local host because we are using a single VM where everything is running as a separate process. It is running with good health. The role status is shown as started. The health is considered to be good. Hive is not in any maintenance mode. Next, let us try to understand commands section. In the command section, it will display the currently running commands as well as the recent commands that have been executed against Hive on this particular VM. Let's go to configuration. Inside the configuration, there are number of properties and values set. As we discussed previously, all the configurations can be centrally maintained through Cloudera Manager, and deploying the client configuration is pretty easy. Before we try to deploy client configuration, let us try to understand couple of configuration properties and the values that have been set here. Under service wide, we can see that the map reduce option is set to map reduce. As we know, whenever Hive queries are run in the backend, under the hood, MapReduce job is executed. Since we are using only MapReduce and we are not using yarn, at this point, choose MapReduce. Now, let us try to understand Zookeeper service. Hive will use Zookeeper to safeguard against corruption in concurrency scenarios. That is, when multiple users submit a query against a table, Zookeeper will make sure that queries are submitted to the cluster in an order. Now comes the important property in Hive, that is hive.metastore.warehouse.dir. This is a Hive warehouse directory. That is, this is the location inside HDFS where Hive tables are stored. As we know, even though Hive gives a data warehousing platform on top of Hadoop, ultimately data is stored inside HDFS. For data to be stored inside HDFS, there has to be a particular path under which Hive stores the data. Hive warehouse directory property will provide the value where the data is ultimately stored inside HDFS. As we can see from here, user/hive/warehouse is the warehouse directory location where Hive defaults for its warehouse directory. At this point, let us try to access Hive and proceed to create a database and a table. Then let us observe how the warehouse directory gets into the picture, how the tables as well as databases gets created under the warehouse directory. The rest of the configurations inside Hive are dealt in the next session. Now, let us access the command line interface by accessing the terminal. Click on this terminal. Inside this terminal, to increase the font size of the commands inside a terminal, enter Ctrl+Shift++, or we can increase the font size by zooming in. Now let us proceed to access Hive. This will take us into a Hive shell. Now as we can see, we can observe here the Hive version. We can also observe that the Hive which we are using is currently part of CDH 4.6 jar files. All the commands that we run inside the Hive will be stored in a Hive history file as shown here. Please note that as we are logged in with Cloudera ID, all the commands that we run through Hive will consider the user as Cloudera. In real-time projects, You will be logging into any server where Hive binaries are installed for you to access and run the Hive commands. If you log in with your user ID and execute Hive commands, then all the jobs will be submitted to the cluster with your user ID. Before creating databases and tables inside Hive, let us try to understand how the structure is laid out. First, whenever we create a database, what we are basically doing is we are creating a storage for all the tables which belong to a particular project. Now, once the database is created, we will use this database and we will create all the tables inside the database. Please note that whenever we create a database, as we discussed, the metadata related to the database, whenever we created tables, the metadata related to these tables is stored inside the relational database that we are using to store the metadata, and actual data that is going inside the tables is stored inside HDFS. Now let us proceed to create a database. Then we will create a table inside the database. Then we will verify the location of the database as well as the table inside HDFS. In this example, we are creating a database by using a create database command, and we have provided the database name as test_databases. Let us execute this query. As we can see from here, the test database is created successfully, and it also displays time taken for test database to be created inside Hive. Let us use the test databases and create a table inside the test databases. To use any database, use the command use and then database name. Now that we are inside the test databases, let us proceed to create a table. In this example, we are creating a table called test_table with the help of create table command. The test_table has a single column and the column name is COL1, and the data type of the column is defined as integer. In the section 3, we have a detailed video tutorials on working with databases and tables. For now, just try to understand that we have created a database, we are using the database and creating a test table inside the database. Once we executed this query, test_table is created. HDFS name node is available on port 50070. Here we can see that name node is up and running and it is active. Let us browse the file systems and see whether the database and the table have created directories inside the warehouse directory. Let us go through the browse the file system option. Click on the user, Hive, warehouse. Inside the warehouse, I have created multiple databases. We can see that the test databases that we just created is also present. Inside the test underscore databases, we have also created a table called test underscore table. As you can see, the test underscore table is also created inside user Hive warehouse directory. Let us do a quick recap of what we discussed inside this section. In this tutorial, we downloaded a Cloudera VM from Cloudera website. We configured the VM. We understood the different properties inside Cloudera Manager. Then, with the help of command line interface, we also observed that once the database and tables are created, the data and the file structure will get modified at HDFS level. The syntax and the metadata about the tables will be stored in the Metastore database. I thank you for watching this tutorial. We will meet again in the next tutorial. In this tutorial, let us learn different Hive command line interface commands. These commands can also be used through beeswax interface. First, let us try to understand the command through which we can find out Hive version. Then we will try to work out Hive verbose mode. We will understand how to set parameters inside Hive. Then out of all the parameters that have been set, let us grab a particular property and see the value of this property. Then we will understand how to run batch Hive queries through a HQL file. Then we will try to understand how to set up current working database. Then with arrow keys on the keyboard, we will show you how to recall the old Hive commands. Then we will understand the history file location, which stores all the Hive commands that have been run under a user ID. Then we will try to understand how to run Linux commands from a Hive shell. Then we'll also try to understand how to run Hadoop commands from the Hive shell. Let's log into our VM and go through all these commands with examples. Let us spend some more time on Hive shell and understand different commands. To know the version of the Hive that is currently running on the system, type hive -version. This will show that the current Hive version is 0.10 and it is part of Cloudera distribution of Hadoop CDH 4.6. When we run a command like show databases, after the query is executed, we don't see the query information in the output. If we want to have the information of the query also in the output, we can work with Hive-v, which provides verbose mode. Now we can observe that after we ran the show databases here, we can see that same query is echoed in the output. Inside the Hive shell, we can also set parameters and values. Let us try to set mapred.reduce.tasks in this session. If we want to retrieve all the variables that have been set, we can use the set command. Let us see from the set command if we can find out the warehouse directory information. Here we can observe that hive-s -e and we have given the set command inside double quotes. As it displays number of properties to the console, we are trying to pipe the output to a grep command which will only grep the value of warehouse inside the set properties. Here we can see that as per our setting, hive.metastore.warehouse.directory is set to user hive warehouse. This way of running the commands without actually logging into Hive is called one-shot command. Users may feel convenient to run this kind of queries rather than login into Hive interactive mode every time. Hive queries can also be executed from the files. In this scenario, let us try to create a file with Hive statements inside it, and then we can execute the HiveQL file without actually logging into Hive. Okay, now we have created a hive test.hql which has a couple of comments. We are running this file with hive-f option and providing the path to that file. As we have seen, we have written a file with couple of create database commands. Now let us proceed to execute through hive-f option. The output here shows that the first command as well as the second command are executed without any issues. Let us cat this file. Let us log into the Hive shell and see whether these two databases are created. Show database command helps us to see the databases. Now that we can see there are two databases created along with the test database that I created before giving this demo. Now let us use test database 1. Imagine a scenario where you are working under multiple databases and you are creating huge number of tables. In such a scenario, you would be really glad if the command line prompt will show you exactly in which database you are working. For that, Hive has a property. If we set it to true, then whenever we work inside a database, we would be knowing which database we are working. We are setting hive.cli.print.current.db value to true. This will make Hive to print current working database. As you can see here, Hive is followed by the database in which we are currently logged in. Let us exit out of this session. Let us relog into the session and see if this value whatever we have set in the previous session holds good. As you can see here, whatever settings we have done to the previous session holds good until we log out of that session. Even though we had set the parameter of hive.cli.print.current.db to true, in this session we can see that even after using the test database 1, we are not able to see exactly inside which database we are working. So let us set this property again. Yes, now we can see that we are inside test database 1. Hive also gives us ability to autocomplete. That is, when you type off of the command and hit tab, it completes the command for us. Let us test that out. Let us type couple of letters in create. Hit tab. As we can see, it has completed the command for us. If we type the tab key at the prompt itself, we will get a reply like this. So it is asking, there are 413 possibilities. Do you want to proceed to display? At this point, let us say no and exit out of this. As we have seen in the past, we can also use up and down arrow keys to scroll through previous commands. Hive saves all these lines into a Hive history file. Let us think of another scenario where we have logged into Hive CLI, but we want to run some basic shell commands like ls. We just need to enter exclamatory mark, space, followed by the command that we need to run on the shell. This shows that the current working directory is /home/Hive learner. Let's try to run another command. We can see that the earlier script that we created, that is hive test.hql, is present under user's home. We can also run Hadoop commands from inside Hive. We can see full listing of help on the options supported by DFS using this command. DFS-help command will help us to show all the Hadoop commands that are available to run on Hive. In the next tutorial, let us discuss more on other configuration options. Hi everyone, in this video tutorial, let us understand Hive Server 2 architecture. Proceed to install Hive Server 2 on our VM with the help of Cloudera Manager. Then we will tweak configurations in order to make Hive Server 2 to connect to the Metastore process. And let us run a couple of commands using beeline command line interface which connects to Hive Server 2, which eventually connects to Metastore process and the database. As we discussed in the previous tutorials, any process will have a memory, port, set of configuration files, and a set of log files where it will write the log output. Since Hive Server 2 is a process, even it will have its own memory, it will be listening on a port, it will have its own set of configurations, and we can check the log file locations as well. Cloudera recommends running Hive Server 2 instead of Hive Server 1 package in most of the cases. At any point of time, in a cluster, we can run both Hive Server 1 as well as Hive Server 2. Hive Server 2 is a server interface that enables remote clients to connect to the Metastore to execute queries against Hive and retrieve the results. Even in real-time production implementations, the other big data analytical tools like Datamir, Platfora, or Talend would connect to the Hive Server 2, which will connect to the Metastore process to work on Hive metadata tables. Let us log into our VM and proceed to install Hive Server 2. Before we proceed to install Hive Server 2, let us bring down the Hive Server 1 here. As you can see, Hive Metastore process for the Hive Server 1 is successfully stopped. Let us go back to the services, choose all services. To install any new service, click on the topmost actions button, add a service. As we are installing Hive, choose Hive, click on next. Now Cloudera Manager will prompt us for dependencies for the Hive to be successfully installed. Those dependencies are Zookeeper needs to be available, HDFS should already be configured, MapReduce should already be configured. So let us choose this option because we are not worried about yarn. Under the host assignments, since we have a single host, we are seeing only one host here. In a production instances where Hadoop is generally installed on hundreds of servers, Cloudera Manager will give us ability to install Hive on any of the 100 servers. So here, along with the single host, you will have rest of the 99 servers under the host list. For now, since we are installing Hive on our VM, which is a single server, so let us proceed to choose all these components on this server. We are choosing. I will try to see if I can give a separate session on web hcat server in the end. Choose Hive server 2. Continue. Now we are installing Hive server 2, whereas the Metastore database is embedded 1. As we have seen in the previous Hive installations, the embedded database is the PostgreSQL. So let us proceed to install Hive server 2 with PostgreSQL as its metadata database. Let us test the connection. Connection is skipped here because database is not yet created for Hive 2. As we have discussed previously, the configuration review page displays the Hive warehouse directory information as well as Hive meta server port information here. Since we already have Hive server 1, which is using user Hive warehouse, let us proceed to modify this path and port as 9093. Accept these configurations. Now the cluster is prepared for the new service, that is for Hive server 2. Let us understand each of the steps. First, it is trying to start Zookeeper service. Since Zookeeper is already running, it has skipped this step. Then it tried to start HDFS service. Since HDFS service is already running, both HDFS as well as MapReduce steps are skipped. It has created a Hive Metastore database. That is, if we log into the PostgreSQL database, we would be able to see as a database for Hive server 2. So it has also created all the tables related to the metadata. It has created a user warehouse directory as we mentioned in the configurations, that is user Hive server 2 in the HDFS. Then it has started the Hive service. Then it has deployed the client configurations for the Hive service. Let us hit on the continue. At this point, we can congratulate ourselves because Hive server 2 is successfully installed. Let's hit on the continue. There we can see Hive server 2 under services. Let us try to bring up Hive server 1 services as well. Hive 1 has been brought up successfully. Let's close this. At this point, as discussed in the concept section, our VM is configured with both Hive 1 as well as Hive 2. Under Hive 2, we have our Hive server 2 process. Let us test beeline command line interface. To connect to beeline command line interface, type beeline. As we can see, beeline version is 0.10. Let us connect to the Metastore through Hive server 2. Here we are connecting to Hive server 2, which is running on our local host. on port 10,000 with the help of JDBC. Let us proceed to connect. It is prompting for the username. As we have not defined separate username and password for connecting to the Hive server 2, let us just enter. Now beeline command line interface is connected to the Metastore with the help of Hive server 2. Let us give our usual show databases command. As we can see, only the default database is present. Let us proceed to create financial database as we created using command line interface. Perfect. We are able to connect to the Metastore with the help of Hive server 2 from the beeline command line interface, and we are able to create database inside the Metastore. Let us go to Cloudera Manager and go through some of the configurations related to Hive server 2. Click on Hive server 2, configuration. As we can see, Hive server 2 log directory is var log hive. Hive server 2 enables impersonation. Inside Hive server 2, under advanced configurations, we can enable automatically restart process so that in case of a failure of Hive server 2, this process would be restarted. Under ports and addresses, we can see that Hive server 2 thrift port is 10,000. During our demo on beeline command line interface, we have used this port to connect to the Hive server 2. Click on the logs. The logging threshold is info here. The Hive server 2 maximum log file size is 200 MB and Hive server 2 maximum log backups are 10 logs. That means at any point of time, Hive server 2 will store 10 logs, each of 200 MB size. The process should have a memory. So the Java heap size of Hive server 2 will specify how much memory is required for Hive server 2. As we have seen in the previous cases, the Metastore heap size as well as the bspax heap size is always set to 6 GB in production environment. It is recommended even we keep Hive server 2 memory to a higher value close to 4 GB or 6 GB. Configuration files hive-site.xml and hive-env.sh can be located under etc hive conf.cloudera.hive2 folder. Let us try to view hive-site.xml. As we can see, hive.metastore.local is false. Property Metastore URI is listening on 9093. Generally, Metastore will listen on 9083 port. Because we already have another Metastore service on this VM which is using 9083 port, we are using 9093 port. Hive Metastore warehouse directory is user Hive warehouse 2. That is, whenever we create a table by using Hive server 2, table will be created under user Hive warehouse 2. Hive supports concurrency, so this value is set to true. We are using local zookeeper. Let us proceed to do a quick recap of what we learned in this session. We understood basic architecture of Hive server 2, where exactly the Hive server 2 process fits into the overall Hive architecture. We installed Hive server 2. As Hive server 2 is a process, it has its own memory, which we generally keep it to 6 GB in production environments, and it listens on its own port, that is port number 10,000. It has its configuration under etc/hive and the log files are located under varlog hive. We also went through a quick demo of using beeline command line interface where it connects to the Hive server 2 with the port information, which eventually connects to PostgreSQL database. Other analytical tools can also connect to Hive server 2 by reaching on the port 10,000. Thank you for watching this tutorial. Hi everyone. In this tutorial, let us proceed to work on databases in Hive. In Hive, the concept of database is just a catalog or a namespace of tables. It is important to create databases before we create tables so that permissions can be given to users at database levels. It also avoids table name collisions. If we don't specify a particular database while creating a table, the default database is used. In this tutorial, let us try to understand how to create a database, describe a database, alter the database, and finally how to drop a created database. Let us proceed to log into our VM and start running the commands on our shell. Simplex syntax for creating a database is create database and provide the database name. In this example, we are creating a database called movies. As you can see, the database is created successfully. Hive will throw us an error if the movies database already exists. So to suppress these warnings, we can provide another variation of create database command with if not exists keywords. In this example, we are creating a test database with if not exists keyword. This is very helpful if we do not want to receive warnings while creating databases on the fly. Let's execute this command. As you can see, the database is created successfully. We can see the databases that are already present within the system with show databases command. Show databases command will provide the list of all the databases that are present in the cluster. If we have multiple databases inside the cluster, we can use regular expressions for a particular database. In this example, let us try to grab the database inside the cluster which starts with the letter M. As we can see, movies and MySQL test databases are only displayed. We can also add a comment which will help us to understand more about the database. Let us create a database by adding a couple of comments. In this example, we are creating a database called movies_database with the comment stating that this particular database holds user ratings on all the movies. Let us run this query. Now that we have successfully created different databases, let us use describe command to understand about a particular database. In this example, we are describing about the database called movies. As we can see, whenever a database is created, Hive will create a directory inside the HDFS under the warehouse directory. All the tables inside the database will be stored in the subdirectories of the main database directory. DFS command helps to run Hadoop commands on the Hive command line interface. Let us check inside the warehouse directory with the help of DFS command. Movies directory is created inside user Hive warehouse directory. We can override this default location of warehouse with a new directory location under preferred path for a particular database. In this example, we are creating a database called accounting under user/Cloudera path. Now that we have created some databases and we have checked the database directory locations inside HDFS through describe command, let us proceed to alter the databases. Once databases are created in Hive, we can only alter the database properties. No other metadata properties can be changed once the database is created. If we want to change the database name or change the database directory location, we need to drop the database and recreate a new database. Let us proceed to alter the existing database and set different database properties. In this example, we are altering the properties of movies database. Let's execute this. Finally, in this section, let us proceed to understand how to drop a database. A database can be dropped with just a simple command like drop database and database name. We can also pass if exists optional parameters in order to suppress the warnings if database doesn't exist. By default, Hive does not permit to drop a database if it has any tables inside it. To drop a database, first we need to drop the tables inside it or append the keyword cascade to the drop database command. Let us first use a database and create tables inside it to work on this. Now we are proceeding to create tables inside the movies database, and to show the current working database, we need to set a command line property hive.cli.print.current.db equals to true. As you can see, the Hive prompt is showing the current database that we are working on. We have completed creating a test table inside movies database. Let us try to drop movies database and see how Hive prompts us for an error. As you can see here, database movie is not empty is the error message when we try to drop the database movies, because it has a test table inside it. Run the same command with cascade option. With cascade option, the drop database movies command went to success. In this section, first we created a database and then we described the database with describe database command. We altered the database properties with alter database command. Finally, we went through an option of dropping the database. In the next session, let us proceed to understand different data types that are used for creating tables. Thank you for watching this session. Hi everyone. In this tutorial, let us understand the difference between schema on write and schema on read. When we write data into a traditional database, the database has total control over the storage. The database is more like a gatekeeper. This gives ability to database to enforce schema as data is written. This is called schema on write. Let us say we are creating a table called user, which has two columns, name and age, where name is defined as string data type and age is defined as integer data type. If we are trying to load sample data as shown here, the load statement will fail because we are trying to load a string for a column which is defined as integer. This is called schema on write. That is, schema is verified while writing the data. This makes loading the data a slower process in traditional databases. When it comes to Hive, Hive has no such control over the underlying storage. There are many ways to create, modify, and even manage the data that Hive will query eventually. Therefore, Hive can only enforce the schema while reading the data. This is called schema on read. In this example, let us say we have created a table called user with name and age as string and integers respectively. And if we are trying to load these values into a Hive table, the loading will be successful. Whereas when we are reading the data from this table, let us say we have given a select star from this table called user. While reading the data, Hive will verify the schema here. As Pete is not an integer type, null value will be displayed instead of Pete. As the schema doesn't match the file contents, null values will be displayed for the fields where schema mismatch happens. Rather than verifying the data when it is loaded into the Hive, it verifies the data when a query is issued against this data. Since the data need not to be read, parsed and serialized while it is written, loading the data is always faster in Hive. To summarize, when data is loaded, schema is not verified in Hive. Whereas, schema check happens while reading the data. If there is a mismatch between the schema and the dataset, then null values are returned in Hive. Whereas in traditional databases, database has more control over the data that is returned to the disk. While loading the data itself, in traditional databases, the data is verified against schema. This makes writes slow in traditional databases. Thank you for watching this tutorial. Let us meet again in the next tutorial. To download movies dataset, log into your virtual machine, then navigate to grouplens.org site. This site